Hello and welcome to another section in further mathematics. In this section we'll be looking at composite mapping. We'll be talking about composite mapping. Before that, let us review the previous lesson. Okay, welcome back. A mapping is composite when the codomain of the first mapping is the domain of the second mapping. Consider the mapping where the function of f, z implies z and g, z implies y. So when you have this, you know that the image, the codomain of A serves as a domain to another. That is just a transitive mapping whereby an image is being reflected and transferred to another point. So this is what we call composite mapping. You know, before now we've been dealing with mapping where we have the domain and the codomain. This is the codomain, this is the domain. Now you have 1 2 3 1 2 1. Now if this serves as a codomain and this is the domain, before now we call this this is just mapping and function. Okay, but in a situation where you have this is the domain, this is the codomain. If you now have another codomain whereby the codomain of the initial mapping serves as a domain to the second mapping, then you now call it a composite mapping. Now the mapping F takes an element in X and produces an image in Z, and then the mapping G takes an element in Z and produces an image in Y. It can be denoted by GF or G of F. So this is an example of a composite mapping when you have more than one domain. So this is not actually a real domain. It is called a pseudo domain. Thus it exists as both a domain and a codomain. So it's just like a false domain, or will you just say okay, a latent domain. That is to say, it's not that visible, as you can't just picture it as a complete domain, but it plays the role of both the domain and the codomain. So I would like us to try some questions that have to do with composite mapping. For example, if we have let's call this example 1. Let's say for example we have the domain. Remember, we are dealing with composite mapping. We also have another, okay, we have its codomain, and we also have another codomain. You know, this is a composite mapping whereby you have three different images. We have 4, and let's put 2 here, and let's have 9, 5 and -5, and let's also have 10, let's have 10, and let's have 18. Okay, let's produce the mapping here to here. Let's create it this way. These are codomain. Now at this same point, our codomain will now act as a domain to another function. So we now have it this way and this way. So let's call this our f value projected, the image which is G progresses. So this way. Now with this example 1, let's determine the following values. A, let's look for f minus 3 plus f4. B, let's look for f2 plus f minus 5. C, let's look for G. Then we have the value of our f minus 3, and D, I would like us to look for G minus 3 plus G, where F is 4. Now let's look for this 4 points. Now what I want us to do is, remember it's a composite mapping, so let's go to the first one, A. With this we said F minus 3. Now these are minus 3. This is the value of minus 3. Now where is the function of minus 3? It's minus 5. So you write minus 5 plus, now our F4 is this F4. F4 is what? 9 plus 9, which is equal to 4. The first one here is 4. Now let's go to the next one, F2. F2, our F2 here is 5, because it's the only one that is left here. So our X2 is 5, and our F minus 5, that is here, this point, gives you what? 10. So you now 5. So we now have plus minus 10, which is equal to minus 5. Now our GF of minus 3 is equal to, this is our G of F of minus 3. That's the image of F in minus 3. So this is minus 3, comes to here and goes up. So this is the point, is equal to minus 10. And the last one is G of minus 3. Now where's our G of minus 3? Our G of minus 3 is equal to G, that is minus 3 is equal to G minus 5 plus our GF4. Our GF of 4 is equal to 9. So we look for G9. Our G9. So at this point, our G minus 5 will now be minus 10. And our G of 9 is 18 plus 18 equal to 8. So this is the solution to what we have right in front of us. Now I would like us to move further to inverse mapping. Now when you talk about inverse mapping, it's just like the transpose, the opposite of the actual mapping. For example, if we say, let's call this example 2, we say the function f is defined on the set of real numbers by f of x being equal to x minus 1 over 3x plus 2, where x is not equal to 2 over 3. Now this is it. Now find f inverse, that's A, f inverse of x, B, f inverse of minus 2, and C, largest domain of f inverse of x. Now let's start solving. We have to produce 3 different parts of a screen. So remember, we have the first part is f x equal to x minus 1 over 3x plus 2. So we want to get the inverse of x. Let's make y the subject of the formula. Okay, the inverse of x, we now have this is equal to y, which is equal to x minus 1 over 3x plus 2. Now let's make y subject to the formula. We multiply. We have y. Now these are x. We now have y 3x plus 2 is equal to 2x minus 1. So this is equal to 3xy plus 2 plus 2y to be equal to 2x minus 1. Okay, the value of x, let's take our x term together. We now have 3xy minus 2x is equal to minus 1 minus 2y. So with this, we proceed by writing our value of x to be equal to 3y minus 2, then equal to minus 1 minus 2y. So our x is equal to minus 1 minus 2y all over 3y minus 2. So this is our inverse of this, our x inverse. Our x inverse is equal to this. Okay, so with this, the value of our f inverse is equal to minus 1 minus 2x all over 3x minus 2. So for f minus 1 minus 2 inverse is equal to minus 1 minus 2 times minus 2 times minus 2 over 3 times minus 2 minus 2. So the value of our f minus 2 inverse of minus 2 becomes equal minus 1 times this, that is, we now have plus 4 over minus 6 minus 2, which is equal to 3 over minus 8. That's the value. Then for the c part, the largest domain of fx, now we say the largest domain is all real values, is all the real values of x except at 2 over 3. So I would like to say a big thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will be appearing on your screen shortly. Do well to use the lesson notes on the platform for better information on the topic we've discussed.